All right, everybody. So this is the first PowerPoint for Chapter 5. So in Chapter 5, we get to our first organ system, the integumentary system. And then for the rest of this course and Anatomy 2, you're going to go organ system by organ system. Okay, so the integumentary system is skin, hair, and nails and associated structures. So the integumentary system, because your skin is also called the integument, is the largest organ of your body. It's as big as you are. It makes up about 16% of your body weight and 1.5 to 2 meters squared of surface area. Now we can divide this entire organ system into two major areas. The cutaneous membrane, which we learned in an earlier chapter, that's our skin, and all of the accessory structures. So the cutaneous membrane or skin has an outer layer called the epidermis, which is made of stratified squamous epithelium. And then it has an inner layer called the dermis that's made of connective tissues. Now, they are not evenly split. The epidermis is a very, very thin layer compared to the dermis, which we're going to see in the models. Accessory structures, which make up the other half of the integumentary system, all start in the dermis and then go through the epidermis and stick out at the skin's surface. So things that would be accessory structures are hairs and hair follicles, exocrine glands like sweat glands and sebaceous glands and ceruminous glands and mammary glands, and your fingernails and toenails. Okay, so all of those are going to be on the accessory side. The integument has lots of blood vessels and sensory receptors. Sensory receptors are going to belong to the nervous system and therefore feeling and interacting with the environment. Then below the skin, there is something called the subcutaneous layer or hypodermis. The prefix hypo means under, and the lowest layer of the skin is the dermis. So the hypodermis would be what is under the dermis. It's made of loose connective tissue, primarily adipose tissue, and as I mentioned, it is below the dermis. So here is a model. This looks very much like the model I gave you photographs of for lab. So here at the top, from this wavy line, all of this purplish blue and this tan, all of this is the epidermis. It's just this little tiny bit. And then we have from here down to here is the dermis. And the dermis can be split into the upper edge that goes up and down. That's called the papillary layer. And then the lower area, that is the reticular layer. Now, this is epidermis, this is dermis, and then down here where we see these big fat yellow fat cells, that is the hypodermis or subcutaneous layer. Here are where the accessory structures are going to be. So here is a hair follicle, and here is a hair coming up out of the follicle. Here is a sebaceous gland. This is a skin oil gland. Here is a sweat gland. Okay, now we don't see any nails on this because we're going to see those a little later in the chapter, but those are the accessory structures. The integumentary system has lots of jobs. Its foremost job is it is the barrier for your whole body, the way the cell membrane is the barrier for the cell. So it is the first defense. It's your protective layer that keeps you contained and separated from everything else in the environment. It protects underlying tissues and organs. It also is an active tissue. It excretes water, salt, and waste in the form of sweat. It helps you control your body temperature. It produces a pigment protein called melanin, which gives your skin its beautiful color. It produces a waterproofing protein called keratin. It helps you make vitamin D3 and activate it by going in the sunlight. It helps store lipids in the hypodermis. It helps you detect touch, pressure, pain, and it helps coordinate the immune response. So it's a very, very busy organ system. So again, this kind of divides up what we've already seen. The functions of the integumentary system are across the top. And here is the cutaneous membrane, and it's divided into epidermis and dermis. And then dermis is divided into papillary layer and reticular layer. And then over here we have our accessory structures. We have hair follicles, we have glands, and we have nails. So let's start at the top and work our way down. We're going to start with the cutaneous membrane, and we're going to start with the epidermis. The epidermis is 100% made of stratified squamous epithelium. It is avascular. It has no blood vessels, just like all of our other epithelia. And that means that it's dependent on another tissue for all of its nutrients and oxygen to be delivered by diffusion. And since the dermis is right below the epidermis, that's where the oxygen and nutrients will come from. Now we have lots of different cells in the epidermis. The biggest, most abundant one is called the keratinocyte. And you can see keratin in its name. That's the protein that we're going to add to our cells to make them nearly waterproof. So if we were to take your skin edge and we pull off the epidermis, this is what you would see. Underneath, the top part of the dermis is up, it goes up and down in these little peaks that are called the dermal papilla. That's why this is called the papillary layer. And then we have the epidermis, which follows the same shape. So the basement membrane of the epidermis is this darker purple line here. And then we have lots of rows of cells. And then the very top layers of the epidermis are going to be flat, dry, dead cells. That's why it's stratified squamous. Now there's going to be two different kinds of skin on your body. There is thin skin, which is on most of your body, your arms, your legs, your face, your neck, your back, everywhere except your palms and your soles. And in this, we're going to have this basement membrane. We're going to have several layers, and then we're going to get up to the top layer here. And it's not a very large distance in thin skin. And there are 4 kinds of cells, layers of cells that are going to be in here. And we'll see those in just a minute. So thin skin, again, covers most of your body and has 4 different varieties or characteristics of keratinocytes. And these letters will make sense a little bit later in the PowerPoint, okay? Thick skin, which is only on the palms of your hands and the soles of your feet, has a 5th category of keratinocytes. Notice that this L appears. And it also has a lot more of the top layer, which is called the stratum corneum. So here is a difference with a microscope between thin skin and thick skin. So this would be on the back of your hand, and this would be on the front of your hand, on your palm. So again, this starts way down here and goes all the way up. This is why it's called thick skin. We have a lot more of this top layer called the stratum corneum, and we have a new layer in here called the stratum lucidum. Now, this is giving you those layers and their characteristics. I'm going to kind of explain them as well in this PowerPoint, so I'm not going to go into them right this second. Okay, so the 5 different kinds of keratinocytes have characteristics that they take on as they are transformed from a brand new round cell that is not waterproof and get moved up towards the surface of the skin. And as we move it up, we begin making more and more and more of the protein keratin. Keratin makes the cell waterproof, or mostly waterproof. But the problem is that a cell full of keratin can no longer be alive. So as we move from the bottom layer, the first layer of the epidermis, towards the surface, we're going to start with no keratin, and we're going to get more and more keratin, and we're also going to start out as alive, and by the time we arrive at the surface, the cells will be dead. Okay, now these are the layers of the skin starting at the basement membrane and going upwards toward the surface. So each layer is called stratum because a stratum is a layer. And then this is the important part. So they go stratum basal, stratum spinosum, stratum granulosum, stratum lucidum, and stratum corneum. Now, since there are 5, you know we're talking about thick skin. Now, what I've done is I've arranged them the way they would actually be. Basal would be on the bottom because it's the base. And then this is going up towards the surface of the skin. So this will be towards the dermis. This is towards the surface. And notice I've highlighted these letters. I have 2 mnemonic devices that will help you remember the order. And you can decide which one sticks in your brain and helps you remember better. This one, you start at the bottom and go up with your saying. And you say, boys say girls love chocolate. So that tells you the order from the bottom layer of the epidermis up to the skin surface. Basal, spinosum, granulosum, lucidum, corneum. If that is too hard to go up, you can also go down from the outer layer down, and you can use this one, and this one says, crazy lovers get strange bacteria. So whichever one sticks in your brain better, feel free to use it, okay? Now we're going to talk about each of these layers and why they are named what they are and what are their characteristics. So, stratum basal, you can hear the word base in there. This is the basal layer. This is one layer, one row of cells, and these are basically the stem cells for your epidermis. So these are constantly undergoing mitosis and dividing. One of them stays in the stratum basal, and the other of the daughter cells produced in mitosis gets pushed up to the next row. Okay? So the basal is never more than one row. And then as soon as they divide, the second cell gets pushed up to the second row. It enters the second category. Now, this is the first row of cells of the epidermis, so it is attached to the basement membrane by hemidesmosomes. And it is dependent on the papillary layer of the dermis for all of its nutrients because it does not have blood vessels. Now, the stratum basal goes up and down following the papillary layer. And so it will make these things called epidermal ridges. Since we're talking about thick skin especially, if you look at your fingertips, you have ridges that make your fingerprints. And that's from this up, down pattern of the dermal papillae under the stratum basal. It says it's also called the stratum germinativum. Nobody says that. Don't worry about that. Okay. All right. Now, inside the stratum basal, we have a few other things besides the keratinocytes. We have some nervous system structures called tactile discs. Tactile has to do with touch. And so these are sensory receptors that when they are touched, they send an electrical current to your brain. And so these are very close to the surface of your skin. They're very sensitive to touch, very, very light touch. They're especially found in hairless skin. Now, very few parts of our body don't have hair on them. Our lips, our nipples, and parts of our external genitalia. That's it. Everywhere else you have hair, even if it's fine hair. You will also find a cell in the stratum basal called a melanocyte. And these are ones that make and hold the pigment melanin. We'll talk more about that in the chapter later. Stratum spinosum is the next layer up. So as soon as we move that cell up into the second region, we begin making keratin. Now, when we start to fill the cell with keratin, it starts to actually contract a little bit because that protein kind of starts to dry it out. So where we used to have the cells connected by desmosomes, when the cell membrane contracts a little bit, it exposes those desmosomes and they look like tiny spines around the edges of the cells. That's where this layer got its name, the spiny layer. Now it's actually 8 to 10 rows of cells that belong to the stratum spinosum. So this is from the row just above the one row of cells, that's stratum basal, up 8 to 10 rows. Now in here we're going to find another kind of cell called a dendritic or Langerhans cell, which is part of the immune response. Now, by the time we get to the third region of cells in the epidermis, we have so much keratin that it begins to clump up inside the cell into granules that are visible. And so the name of this third area of the epidermis, this is called the stratum granulosum. And it's only 3 to 5 rows. But by the time the cells get here, we have two problems. It has a lot of keratin in it, and it's far, far away from the oxygen source. So from the granulosum to the surface, the cells are dying or dead. It is not compatible with life. The keratin is in a dense granule called keratohyalin. And by the time we're getting these granules of protein, again, the cells are no longer able to stay alive. So they're becoming more and more waterproof, but they are no longer viable cells. Now in thick skin, this is the extra layer that we have that we don't have in thin skin. It's called stratum lucidum because the cells are tightly compacted and light shows through them. It looks like a clear band. And it's only found on your palms and soles, and it covers up the stratum granulosum beneath. And then finally, the very top layer of the epidermis is called the stratum corneum, which is the horny layer. Don't let your mind go in the gutter. It means dried out, okay? So This is the part of your skin that sees the outside world. By the time the cells are here, they are completely filled with keratin, they are dead, and they are water resistant. Now, we all know if we go swimming or in a bathtub or shower too long, water does manage to seep in between our skin cells and we get pruny. And then we have to wait for that water to evaporate and then our skin looks normal again. Now, this can be anywhere from 15 to 30 rows of cells. By far the biggest part of your epidermis. And it has fully undergone keratinization. And so we say it's completely cornified. So from the time the cell undergoes mitosis in the stratum basal until it reaches the bottom part of the stratum corneum is 7 to 10 days. And then after about 4 more days, those cells that have entered the stratum corneum make it to the surface and they slough off. That means they fall off. Every time you touch something, you leave skin cells behind. Thousands and thousands of these skin cells. If you don't believe me, look around your house right now. Because what you see laying on your dresser and your shelves as the form of household dust is mostly made of your dead skin cells. Your cells, anybody who lives with you, and the dead skin of any dogs or cats or other pets that are in your house. Plus, the dust mites that are eating that skin, and the poop of the dust mites eating that skin. Ew. Makes you want to go Swiffer, doesn't it? Okay, so that's what the stratum corneum is the uppermost layer. Now, below the epidermis, we have the dermis. Now, epidermis is always stratified squamous epithelium. The dermis is always connective tissue, and it has 2 layers to it. The top layer, which follows that up and down pattern, is called the papillary layer, and it is made of areolar tissue. And then the tissue changes and becomes dense, irregular tissue, and then it becomes the reticular layer of the dermis. All of our accessory structures have to start in the dermis, like our hair follicles and our sweat glands. So again, the papillary layer is just the top edge. It also has capillaries, lymph vessels, and sensory neurons. And the peg shapes that it goes up and down in are called dermal papillae. That's where it gets its name. Now, those pegs serve 2 important functions. They both have to do with surface area. Just like microvilli increase surface area, dermal papillae will increase surface area. That surface area is needed for diffusion of oxygen and nutrients across the basement membrane to the epidermis to keep the few cells alive in the stratum basal and stratum spinosum layers. It's also needed to maintain contact to hold your dermis and epidermis together. More surface area, more places where hemidesmosomes and things can be stuck together, okay? Now, if anything bothers this tissue in the papillary layer and it becomes red and inflamed and itchy, then you have a condition called dermatitis. This can be caused by infection, radiation, being mechanically irritated like a heat rash, or things like poison ivy. It can be itchy or it can be painful. You can also have damage to the tissue, which causes fluid to accumulate between the papillary layer of the dermis and the epidermis. Those would be called blisters. And as long as the blister is closed, you won't be introducing infection. Do not ever pop a blister, because now you're releasing that fluid out, but you've opened up a huge hole where pathogens can get in and cause infection and scarring. Okay, so the lower layer of the dermis is called the reticular layer, and it's the thicker layer. It's made of dense, irregular connective tissue with collagen and elastic fibers. And basically, the dermis has all the different cells that we saw in the connective tissue chapter. Okay? The strength from your skin comes from the collagen fibers that can bend and twist, but they are not stretched. This lets us be flexible, but limits the flexibility so that we don't damage tissues beneath. Any stretch is provided by elastic fibers. And then between the fibers and the water that they draw in, your skin has a certain amount of pressure behind it that makes it stand out smoothly. That's called skin turgor. Now, if you have damaged your skin, you can lose skin turgor because number one, you're dehydrated. That's reversible. A way to tell if you're dehydrated is to pinch the skin on the back of your hand, and if it stays kind of in the pinched upright position, you're dehydrated. You need to go get some water. If it falls back down and flattens out, then your skin turgor pressure is high enough. You're not dehydrated. That one is reversible. Aging, not reversible, unfortunately. So as we get older, we create fewer and fewer fibers and we hold less water under our skin, so our skin begins to sag. Hormones and shifting hormones during a month can cause changes to your skin. So sometimes your skin has more skin turgor and sometimes it has less. And damage from UV radiation also affects your skin turgor. Now, sometimes you have a huge increase in the size of your body and your skin cannot keep up with production and it actually tears and then has to go in and kind of repair itself. That is called a stretch mark, and it can be caused by weight gain from any reason, like you would weight gain, or pregnancy. They're especially common in the last trimester of pregnancy. Now, although your skin is made of dense, irregular collagen connective tissue, your body's pretty smart. It knows the directions that most of the time different body parts are going to face kind of disruptive forces. So it will lay a majority of the collagen fibers in parallel sequence over those areas that need more strength in that direction. Okay? So these are called tension lines or cleavage lines. Now, for most of us, these lines don't mean a whole lot to us, but they do mean a lot to a surgeon. Because if you cut parallel to the tension lines on the body, then it's kind of like just separating the collagen fibers sideways from each other. And when you are done with your surgery, they will kind of seal back up with very little scarring on your patient. However, if you cut across tension lines, you are breaking those collagen fibers, then they're going to put in more collagen and they're going to get puffed up and you're going to create a very ugly scar. Most patients are not excited about a very ugly scar. So these are what the tension lines look like, and you can kind of see how they make sense. Now this is the front of the guy and this is the back of the guy. Don't freak out, okay? But you can see like along your face, especially plastic surgeons have to be aware of tension lines. Okay, underneath the skin, after the dermis comes the hypodermis or subcutaneous layer. Now, it's not officially a part of the cutaneous membrane. It's connected to it by connective tissue. It helps stabilize the skin. It's where you store most of your fat. There are big arteries and veins, and if you've ever had a hypodermic injection, that's where it went. Where your subcutaneous fat is abundant is actually determined by sex hormones and genes. Some of us have large butts, some of us have no butts. I'm so glad you cannot see me because you guys don't have to worry about what I have. Let's just say, yeah, I was kind of lacking in the butt department. So, but that's genetically determined and sex hormone determined. Oh, this is going to be fun. Skin color. We all have beautiful skin colors and unique patterns and colors. And your skin color is primarily caused by two things: melanin and keratin that are being made in the epidermis. Melanin comes in two varieties. One is red-yellow and one is brown to black. And they're made by those cells we've already mentioned called melanocytes. And they're stored kind of in inclusion bodies, vesicles called melanosomes. Then they're moved into the keratinocytes. Now, darker skinned people have big, larger melanosomes and they tend to have more of the black-brown pigment. Lighter skinned people have smaller melanosomes and tend to have more of the yellow and red pigment. Now, the job of melanin is it's a UV radiation shield. The more melanin you have, the better protected you are from damage from sunlight from the UV radiation. Now, UV radiation causes breaks in DNA, which may or may not be able to be repaired, which is how it causes cancer. Now, this is where the fun comes. So, you guys kind of saw my face, maybe. I'm a very, 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 very pale person, okay? I am Swedish and Italian, but I got the pale Swede and the height of an Italian. It's not a good combination. I married 2 times Irish men, my first husband and my second husband. Now, I have 3 children with my first husband and 1 child with my second husband. Now, the first time I became a mom, I did not understand these principles. So, when you go to feed your baby solid food for the first time, your doctor says always start with vegetables because you don't want them to develop a taste for sweets only. So, you don't start with fruits. And they also tell you to feed the child the same vegetable for a week and watch for allergic reactions. What they don't tell you and should tell you is that you should not start out with carrots for the first week and then feed your baby sweet potatoes and then feed your baby squash. Because the pigment that makes those vegetables orange is carotene. And it will accumulate in the epidermal cells, in the dermis, and in the hypodermis. Now, if you are a very pale person like me and my very pale Irish, Swedish, Italian children, what happened to my babies is I turned them into Oompa Loompas. They were orange. And I was so crazy. I did it 3 times with all 3 of the older children. And I did not learn my lesson until the 4th baby. So 3 times when I introduced my babies to solid foods, I fed them orange food, orange food, orange food, orange food until they turned orange. And it takes weeks for that stuff to go away. So listen to my advice. If you're pale, alternate green vegetables and orange vegetables with your babies, okay? My 4th child, who's 7 now, we were smart. We started her on avocado, so we did not turn her into an Oompa Loompa. So you'll all be happy to hear that on the 4th time, I got it right. Now, this pigment is needed to be converted to vitamin A, which you need to maintain your epithelia, and it gets converted into a pigment called retinol, which is how you see. So this is a very good thing to have, just don't eat so much of it that you turn orange. All right, other things that can influence your skin color have to do with blood flow and how much oxygen is there. So there's a pigment in our blood called hemoglobin that never turns blue. Did you hear me say that? It never turns blue. It alternates between a deep wine color when it does not have oxygen to a bright fire engine red when it does. Now, because of the way our skin and blood vessel linings are, when we see the color of the deoxygenated blood through the skin, it does look bluish. And so the name of that bluish condition is cyanosis. It's an indicator that you are lacking oxygen. It can be caused by cold, heart failure, asthma. You can even cause it if you, like, when you were a kid, put a rubber band around your finger to see what would happen, and you notice that the tip of your finger turns like purplish blue. Okay? That's cyanosis. It can be used as an indicator of a lack of oxygen in a particular area or a whole body lack of oxygen, like when a baby has apnea. Now, that same hemoglobin, by the way, I changed slides, but I shouldn't have, is also responsible for you turning red when you blush or when you get hot. Because when you're hot or you're embarrassed, the blood comes to the surface of your skin. The blood vessels dilate. And now hemoglobin causes you to turn pink or red. Okay, other things that can happen. Jaundice. Jaundice is breakdown of products that are supposed to be broken down by the liver, such as hemoglobin. And when your liver is not able to break down your hemoglobin and other things appropriately, these yellow pigments start accumulating in your eyes and in your skin and give you a yellow appearance. Now, baby jaundice, newborn babies, sometimes their livers haven't caught on yet. And so they're okay. We put them under these things called Billy lights, or we just stick them in the sunshine, and the light helps break down these products until their liver catches on. So jaundice in a baby is not really a dangerous thing. In an adult, jaundice is an indicator of liver failure. It is a life or death situation. So we need to worry about jaundice in adults, especially ones that have hepatitis, not so much about the ones in babies. Okay, if you have a pituitary tumor, you can also have melanocyte-stimulating hormone, which makes you have darker patches. Addison's disease does the same thing. And then there's also vitiligo. So in some cases, your immune system may kill off the melanocytes in patches of the skin. Without melanocytes, those patches don't have any color. And so only those areas where the melanocytes have died, you will see lightened skin. Same thing with an albino, a person who has albinism. They do not make any form of melanin. So their skin, their hair, their eyes, anywhere we would put pigments is pigmentless. So it's very, very pale. Now your skin is also responsible for creating activated vitamin D3, which has the official name cholecalciferol. So you need to go in the sun for at least 10 minutes a day without sunscreen. I know that sounds horrible, but that gives you a chance to activate vitamin D3, and you need that vitamin D3 to be processed by your liver and kidneys so you can absorb calcium from your food. If you don't have activated vitamin D3, you don't absorb the calcium from your food, then you do not have enough calcium to make your bones strong. You may get a condition called rickets. And over here is a patient with rickets. It's a bow-legging syndrome because you take the sunlight and you make cholecalciferol, which goes to the liver and the kidneys, which tell your intestines, hey, take in this calcium and put it in our bones. Okay, so that is the end of this first part of Chapter 5. I'll be sending out the second one soon.